ask a few questions from online.
Sure.
I'll ask from the end. So they're asking, can you explain what the decision function for isolation forest is? Is it mean path length for each transition tree? Sorry, for each decision tree to the data point?
Is a function of it. It's not exact. So here, as you can see, is like that number is not the distance. We can look it up to see how sklearn has implemented that distance function, but is a function of that distance. Yes.
I see. Okay. Another question is, when you have categorical feature that has a huge number of categories, is it still suitable to use isolation first?
I would say still yes, because then the thing that you're doing that you're making you will it depends like how you're encoding your data. If you're making it to be one hot representation, then it means you have lots of then for each feature or dimension it will be either 0 or 1, and then if you have by just one split you should be able to kind of maybe isolate some of the node if you do that per different dimension. So that's why it's like you can't just have maybe one tree to get the result. If you have multiple tree, you should be able to get that result. But that's kind of the thing is, if you're saying that you have the number of categories super high, it means then you will have the number of dimension will be super high as well. And when your number of dimension is super high, usually that's the problem with most of this technique here as well.
Okay. So last one, are you going to discuss any unsupervised algorithms associated with sequence data?
What is the
like time series data,
okay.
For example?
Cluster.
So what was the question?
So the question is, are we going to discuss any unsupervised algorithms for sequence data?
Yes. I was actually trying to put it here as well, and then I was like, as one of the data set, but then I decided not to do that because this algorithm is hard for them to capture the pattern of the sequential data unless you have to do it. So it means I was trying to do that first, and then I decided maybe it will be too much for this workshop. But the thing is, yes, you can use this technique for sequential data as well, but you have to do some feature engineering. So it means, let's say then you have to maybe window your data set, and per window you have to extract some feature. Either you have to say that window is the whole feature that I have, or maybe you have to extract maybe mean, max, I don't know, all those things that you can extract from that sequence of data, and from that moment treat it as a feature. Then it will be exactly like the data set that you have here. So it's like you're converting it to a set of feature per sample, then you will be able to use this technique.
Like, I was just trying to think about this one with like just a regular random forest, because the regular random forest can do feature importance, right? Can this one do it? Because probably not.
The thing is, if you have any cost function or objective or something that a path towards something, then you can optimize it, or you can come up with a weighted sample, or you can say what will be the best direction. It's like in neural network, when you know the cost and you know the gradient and you know which path you should go, so you can move toward that path and toward that goal. But when you don't know that much about any kind of label or cost function, it will be super hard to do that. You can have a weighted one if you want, but the thing is, then it means you are adding some assumption into data set which is different, which has nothing to do with this technique. So, synthetic data. Here we can see how this model will perform. I want to actually use written norm. And see if you have like a a normal distribution in the center of your data space, and lots of kind of noise data. And if I just apply isolation first on top of it, then as you can see, you should be able to capture them, because isolation first can actually find these samples just by dividing randomly with their space. So the thing is, it's actually working. It's fast and it's kind of reliable, right? And then I want to make it even harder for 2 cluster. See, even for 2 cluster, it can manage to get a good number. And you can play with that as well. And then if I switch to the other one, which was a bit harder for, remember that data set was hard for GMM to be able to do that to anything, because the distribution was not normal, was not Gaussian. So GMM was not able to do anything here. And as you can see, random, like isolation first, can still capture these anomalies in your data. So that's why isolation first is, so the whole idea about isolation first or random first or attributes was like, they don't need one super full model, like super powerful model. Maybe the thing you need is lots of maybe weak model. If you have lots of model, which each of them performing maybe not that good, but collection of them will give you a good number.
So is this unsupervised then?
That's unsupervised, yes, because here we don't have label, but yes, because here we have lots of noise in your data set, yes.
Is there some sort of a theoretical result for isolation forests, like the score giving the average word length for identifying a particular data point in a random dictionary from like information theory point of view, something like that? Do you know of any claim like that? Because like when we divide some sort of having a bit of information, but then this bit of information is not optimal, because optimal would be the
certain path. The optimal would be certain path, right? By like G.
No. When we are at a node and we decide how to divide the subset. So if we use entropy as the criterion, then it would be optimal dictionary, optimal encoding from like minimizing the length, the bit length. But we don't do this. We change the threshold randomly, so it is a random dictionary or random encoding. So it's like mean word length or something.
So I'm not sure about any like that explanation of isolation first, but for sure there might be, because that paper is not new. Maybe it's at least 10 years old. So there should be lots of things around it. So as I said, the whole idea was based on a super simple explainable model. So it means, and that was the whole idea of decision tree. And someone asked, when do we not use isolation first? Which might be a good question. Is like, the thing is, when you want to find any kind of outlier, we never know which technique will work better for you, because that's why, to be able to compare them, that will be the best thing. That's why here we didn't say that's the best model or the worst one. We say that's a good that's a model, and people are using it in lots of places. It has lots of advantage as well. It's fast and maybe reliable. But the thing is not, first of all, as you said, is unsupervised models, which means the assumption here is not, maybe one of the key difference between isolation first and the rest is like that. GMM, 1SVM, all those deep learning models we will talk about next session, all the thing that they were trying to do was learning the normal data somehow, one way or another, and then say, if something is not close to my normal data, then maybe that one is maybe outlier. Here in isolation forest is completely looking at the problem in a different way. It says, okay, I don't care about the normal one. I don't want to learn it. The only thing that I care about is, can I isolate a node or not? So it won't learn the data, it won't learn the distribution of the data. The whole idea here is, whatever is novelty, whatever is out there, it should be further from the rest of the data. So it can, so the isolation forest can easily cut it. And if it's not like that, if maybe you have a collection of noises together or something like that, if maybe, let's say if you have 5 nodes super close to each other, then can you isolate them? And those 5 are super far from the normal data. You won't be able to isolate them because they are super close to each other, but they are further from the rest of the data. So that's why. So the whole idea is not learning what is normal, what is not. It's just, can I isolate one sample easily?
But then the problem of this is that, for say, when you have a new data, sorry, then you have to do this
Yes,
all over again.
exactly.
So then it's not a predictive model, right? You cannot really use it for.
If you have a new data, you have to kind of redo it. Yes.
What would be alternative ways to go?
So that's what I'm saying. It's different. If you learn, let's say, the distribution of a data like GMM, then you're saying that I have already learned the data. Give me a new sample, I can compute the likelihood. I don't have to redo it. Adding one sample won't change the distribution.
But for example, I found out that for this like double crescent data set, isolation forest works the best, way better than GMM. And I identified outlier in my initial data set. Now I have a new stream of data coming in, which is size, maybe percentage of the big data. Are there any ways of analyzing new data set without redoing the whole analysis?
Okay, yes and no. Here, okay, I kind of skipped that part, but here, if you see, I didn't create a new model. I just said, I just increased the number of estimation. And as I said, it will just fit the added that tree. So it means, yes, if you want, you can kind of increase the number of tree, and then you can say, okay, now fit the new data set, something like that, if you want.
So it fits and predicts. So I can fit on one data set and predict on the other data set.
Not okay. Then fitting with, okay, you're not completely changing it, because then it will be based on samples. So you have, as I said, is the average of all the tree. So then if you completely change the data, you won't have any score for the new samples. The thing is, like, if you train the data, then each tree will create some score for some of the sample, not all of them. Let's say you are training the tree number 1. It will isolate, let's say, 5 of the sample, and it won't be able to do anything about the rest. Then that tree will give you some score about those 5. For the rest, it will be just max. Another tree, because you're seeing different subsampling of the data, it will give you a score for different sample. So each of these 3 will give you some score per sample. Let's say you have ID, per sample ID, to give you a score. New sample ID will give you some score. So you can kind of make a new tree and then say learn. Okay, then you can give them a new subsample. You see, the whole idea was, you're not trained on the whole data, you're trained on a subsample of them. So for the new data, you can say, no, I'm subsampling from the new added data if you want. So it is possible to add a new sets of data to it, but to be able to be confident about the result, you better to run it on the whole data. And that's one of the algorithms for unsupervised kind of outlier detection, because the assumption is the outlier is already there, and the only thing that you want to do is to isolate it.
But how does it work? Because if I add a single new data point, it can completely change my results.
Yes.
So what was isolated in my build trees is not
So
isolated
it means
anymore.
if you just add maybe 1 or 2, that might be fine.
But how is it fine? Like how?
So you're saying, okay,
Is it just ignoring it? Or?
so the assumption is like that. If you just add 1 sample, it won't increase the density of any area. It will just add 1 more sample to it. So then you can say, still I'm good. It won't change the distribution that much. So still I can be confident about the result that I have. And I just want to analyze the new data to see if I can isolate that one or not. But if you add, let's say another 10 or 20% of the data, then you have to redo it for sure, because then they will change the definition of what layer in your data.
Can I interject? So how are we doing on time? Should we move on?
Yes.
Okay.
So okay, the thing is like that. Then we can talk if you want. Here, as you saw, for isolation forest, even for one of the complex synthetic data, it can actually work kind of cool. It can kind of detect all these outlier in your data set. And I guess I should switch to that one to be able to see what you're saying. So here, because now you have seen how isolation forest is working, I have an exercise for you. As you remember, if you have connected that one to your data set, if you run this one, it will create X and Y, which will be the data from credit card fraud data set. And then the thing I'm asking you is like to make a model, train it, and give me one Y predict, which will be the prediction of the model. It should be something similar to the thing that I've seen here. See, making a model and then making a prediction. Kind of something like this 2 line. And the thing that you're doing here is make a model and then give me Y underline prediction as the output. The thing is, isolation forest has lots of hyperparameter as well. It's like what should be the best number of trees, or what would be, I don't know. There are lots of hyperparameters that you can click on the link and you will see that. And then you can train a model for the actual credit card fraud, and then you should be able to see the result. So as I describe it here, try to make a model, pass the prediction. Here you should, once you run this one, which is evaluation, then you should be able to see the result. Then I want you to report your F1 score to the Slack channel, so you can see who will come up with the best hyperparameter, and that's going to be exercise number 1.
How much time do they have?
Like 10 minutes?
10 minutes?
5-10 minutes.
All right, good luck.
Do we need to split the data?
What?
Do we need to split X and Y to test and train?
No, here no, because you're saying that it's unsupervised, so the noise will be there. So only thing you want to do, you want to say that can you isolate some of the noise, and because you have a label, then you should be able to verify.
Okay.
Can you tell online people to join the video call with Willie?
Yes, join the video call. So, okay. So yes, that's exercise number 1. Please join the video, and Willie will be there to help you as well, and I might join as well. So that's exercise number 1.